Okay, so the GCF. So we move into the next one. The GCF is prime. Just talked about GCF. GCF, though, works for everything moving forward. Okay? Want to get your attention. I even thought about like building a blingy with lots of flashing things. Pay attention to this. GCF is the first step, always. How do I begin factoring? My brain just froze. Take a breath, look for a GCF. Always the first step. Okay? So sometimes that's the only thing you can do, and you're done. What's left over is either linear or it's not factorable or it's prime. Sometimes there's no GCF, but you still have to check. Every time, first thing. Sometimes you can divide out the GCF, but you're still not done. Then you have another step and maybe even a third step. Okay? But if you divide out the GCF first, good job, just keep going. How do you know if to keep going? Well, if what you have left after you pull out the GCF is not linear, then you may be able to keep going.
But if you take out the GCF and if it's correct, you shouldn't be able to keep going.
Well, there may be something else you can do. Another type of factoring. Once you pull out a GCF, you look at what you have left. If it's a binomial that's left, hey, it may be a difference of squares. If it's a trinomial left, it may be a quadratic trinomial that you can unfoil.
But are we going to do that right now?
That's what we're doing right now, yes.
Okay.
So what we just looked at were just like, all you could do is a GCF, okay? So sometimes you just like take out the GCF, or when you're asked to factor, it's like, oh, I pulled out a GCF, there's nothing else to do, okay? But now we're going to do other techniques, but still, no matter what other techniques we do, GCF is still always the first step. And it may be the only thing you can do, or it may be just the first step and you can keep going. Okay? Or you're asked to factor and there's not a GCF, but you checked first because you have to, first step. Checked, okay, no GCF, now I move on. Can I do something different? Okay? All right. So always check for that GCF first, and then you ask yourself, once you pull out the GCF, remember the GCF is part of the answer. The GCF is one of the factors in your answer if there is one. So you're done with it, you keep it, but you're done with it. And you look at what you have left, and you ask yourself, can I keep going? And you look at what you have left, and you say, okay, what do I have now? And if what you have now is a 4-term polynomial, then you use this method. Now, when you first look at this, brain freeze, okay? I'm going to go back to the document camera. We're going to practice a couple of these, and this will make sense. This is more of sort of a reference page that shows you everything you need to know about it, okay? So it may look like, right now, I'm going to turn this off. Let's practice a couple, and then it'll be like, oh, yeah, that just sort of sums it all up, okay? All right. So first let's look at, instead of factoring, multiplying real quick. So take this 2x minus 7, a binomial, times this binomial, x plus 3y, and FOIL it. Okay? So this is not factoring, this is multiplying, the opposite. Okay? So you're expecting 4 terms. They're FOIL, right. So first term times first term. This I do the same thing with whether things are positive or negative. I just see whether I have 2 positives, 2 negatives, or a mix, and that tells me whether it's subtraction or addition. So my outside terms are positive 2x and positive 3y, so I just put a plus sign, and now I just do 2 times 3 and x times y. My inside terms, I see one's positive, one's negative, so that tells me I'm going to have subtraction, and then I just multiply 7 times x. And my last one, I see one is positive, one is negative. That means subtraction. And now I just do 7 times 3, y. FOIL, 4 terms. Now, before you move on, are any of these terms like terms that we can combine and turn this into a trinomial or a binomial? Well, that's an x squared and that's an x. Are those like terms?
No.
Like terms must have not only the same, when you're adding terms, a like term means you have the same base and the same exponent. When you're multiplying terms, you just need like bases, because you're going to add the exponents. But when you're adding terms, like terms mean they look exactly like, same variable, same exponent. So that's an x squared, that's an xy, that's just a plain x, and that's just a plain y, no like terms. So 4 terms when you FOIL, and it stays 4 terms. And look, those are like terms. The first terms are like terms, but these second terms are not like terms, which means that's what I expected. If either my first or my last or both are unlike terms, then when I FOIL, it's going to be done. There's nothing to combine. Okay. So all we're doing here is we're going to take a 4-term polynomial and we're going to go in the opposite direction. We are going to unfoil it. Okay. We're going to take this 4-term and we're going to turn it back into its product of 2 binomials. Okay. So what we're doing is 4-term poly, or polynomial, I'll just abbreviate, 4-term polynomial factoring. And the method for this is the grouping method. And the grouping method means this. And this is sort of a little shorthand way of remembering what I'm doing. So the grouping method is little GCF, big GCF. Now remember, it doesn't matter whether you're capitalized or lowercase. I do that just to emphasize that first you're dealing with 2 little groups, a GCF of 2 separate groups, and then you're going to have 1 overall GCF. That's the big GCF. So we'll look at what that looks like. Okay? But that's sort of my shorthand way of remembering the grouping method. Little GCF, big GCF. Okay? So job 1, you would say, is there an overall GCF? And there's not. 2, 6, 7, and 21 do not have a common GCF, right? But wait, what about like if I grouped them? Now there's not an overall 2, 6, 7, and 21. There's not an overall GCF, but let's if I look at just the first 2, do they have a GCF?
That's what I was saying earlier.
Yeah, oh, okay. Okay, yeah. And what about this one?
7.
Yeah. And so, and also, these have x's in common. Those don't have any variables, but if they have anything, number or variable or both. So overall, there's not a GCF, which I'd still check with first, and if there were, I'd pull it out, and it's part of my final answer. But then I'm thinking, okay, what do I have? What am I working with? I'm working with a 4-term poly. Like, what do? Where do I start? GCF. No. Okay, what do I have? I have 4 terms. If I have 4 terms, I am going to use the grouping method, period. Okay? And the grouping method looks like this. So let me give you an example one. I do want to get to the, okay. So, x, y plus 3x plus 2y plus 6. Okay. 4 terms. Now, in these 2 examples, I'm not going to give you an overall GCF, but you should always check first.
That's a new example?
This is a new example.
Oh,
yeah.
okay.
Yeah, this was just showing how the process reverses, what you get when you FOIL versus going, yeah. So now this is a nice, fresh, a little cleaner example, a little simpler example. But there's 4 terms. No overall GCF, but 4 terms. So I know I'm going to do my grouping method. Okay. So I'm just going to, you don't have to, but I'm going to rewrite it just to say really a clean process here. So 3x plus, xy plus 3x plus 2y plus 6. And I'm going to put up, there's no overall, I can't do anything, I can't factor it as a whole, so I'm going to put it into 2 groups. And I'm going to focus on those 2 groups separately first. Now what we have right here to start with is a 4-term sum. Okay? Term plus term plus term plus term, a 4-term sum. We are not done until all those free-floating pluses and minuses are gone. They're either locked up in parentheses or they're gone. We're going to turn a sum into a product. That's what factoring is. Okay? So, I make 2 little groups, and I look just at the first group, and is there a GCF for this first group? Just the x, right. And what about the second group? It has a 2 in common. Okay? So what I did here was I took out, this is my little GCF. Huh? That's a GCF out of each group. Okay? So I write down my GCF and immediately put up a parenthesis, and what's left in my first group? Right. And this plus sign, notice how when we started, there's a plus sign in the middle, and there's still a plus sign in the middle. When I put up those groups, I didn't put the group around the plus sign. That plus sign is a free-floating plus sign in the middle. Huh? And so it's still there. I just GCF'd this first group. Here's my free-floating plus sign. And now I GCF the second group, that pulls out a 2. Let's make that pink. That pulls out a 2, and I immediately put up a parenthesis, and what's left? Oh, is that looking familiar? Maybe the last thing we just did in the last second, right? So, we started off with a 4-term sum. How many terms do we have now? 2. There's a term, and there's a term. We still have this free-floating plus sign in the middle. So am I done? It is still a sum. I have not finished factoring. If you still have a free-floating plus sign, you're not done. We turned a 4-term sum into a 2-term sum. But it's still a sum. Okay? So, that first round that turned a 4-term into a 2-term sum was little GCF, little GCF. So, how are we going to turn it now into a product? Big GCF, right. And what is, we got 2 terms. What is our big GCF? So that is the overall big GCF there. And so my GCF is y plus 3. So I write down my GCF and I immediately put up another parenthesis. Because that's what GCF parenthesis. Now, that was my first factor. Here's my next factor. When these cancel out, what's left behind in the first term? And then these cancel out, what's left behind in the second term? Yeah, so plus 2. And then close that parenthesis. A binomial times a binomial, which is exactly what a 4-term polynomial factors into 2 binomials. And so a 4-term sum was turned into a 2-term sum, and now it's turned into a product of 2 factors. And both of those factors in this case are binomials. So the 2 factors are binomials. But there's no more free-floating plus sign. Okay? So this is this times this, factor 1, factor 2. If there had been an overall GCF at the beginning before I started, then that would be in front here, and that would be a 3rd factor. So you can't forget about it. Okay? And you can always, always, always now check your work by foiling. Now, it might come out in a different order, but that's okay. Let's see, foil, y times x. Ah, that's xy, right? Okay, check. Okay, outside term, y times 2. Ah, 2y, check. As long as the signs are right, plus or negative, it doesn't matter what order it's in. Inside terms, 3 times x. 3x, check. Last term, 3 times 2, check.
And it's, like, to begin with, negative, you still work it out the same?
If what's negative?
Up there, that free flowing.
Ah, that's the other example, yes. Okay? So no matter what these 4 terms look like, if you've got 4 terms, you already checked for big GCF, you're ready to start doing a 4-term poly, you've got a plus sign in the middle, so you can just put up these 2 groups, little GCF, big GCF, and you're done. Okay? And that's the progression from 4-term sum to 2-term sum to product of 2 factors. Now the one other case, and when we go back and look at that PowerPoint, you're going to see those 2 basic cases there. Okay? So I want to be sure and introduce 9.2, so I'm going to show the other case. I wish I had more time to sort of practice these, but I want you to absolutely look at it in homework and practice. The 2 examples I'm showing you are every case you're going to see. Okay? The first case is when there's a plus in the middle. The other signs don't matter, plus in the middle. So, here's the second case. Let's do xy plus 8x minus 3y minus 24. I'm going to rewrite it so I leave that clean. Huh?
Are we still in 9.1?
Yes. Yeah. All right. So if I say, okay, 4-term, I've checked for a GCF, good. So I've got 4 terms ready to do my grouping, and I just put up my parentheses, leaving that operation in the middle, I'll put my parentheses. Why is this wrong?
Because isn't it a negative 3y?
It is. Minus 3y, but it still is.
It would change the weighted outside?
It would change the what?
Oh, change 24.
Yeah. Yeah, because once you put up the parentheses, you're saying this negative belongs to both those things. If you were to, instead of moving forward, you were going to distribute, yeah, that would make that xy plus 8x minus 3y. Okay, that's not a problem, but plus 24, and that is a problem. Okay. So, if you have a minus, it doesn't matter about these, but if the minus is in the middle, you can't just throw up parentheses because you just changed the sign of the fourth term. That's an illegal move. Okay? So, that minus 24 became plus 24, and this would be wrong. Okay? Don't do that. Okay? So, if you got a plus in the middle, no problem, you're good to go, because if you put up parentheses, you're just distributing a positive one, no problem. But, I'm going to rewrite the same problem, xy plus 8x minus 3y minus 24. If you see subtraction in the middle, okay, then what you need to do is you don't want to change the value of any of the terms. So you're not putting up groups yet. First, you're taking xy plus 8x. If you see subtraction in the middle, change it to plus, because you need a plus sign in the middle. And the only way for that to be legal is if you do what? Right. Make that a negative 3y. Because that's all subtraction is. Subtraction just means adding the opposite. So you're changing subtract 3y to plus a negative 3y. 3y is still negative. And then 24 is not affected by that. Okay? 3y is still negative. 24 is still negative. Okay? So if you've got subtraction in the middle, then change it to adding a negative. And now it's legal to put up your groups. You've got a positive in the middle, so when you put up your groups, and I go back to my original problem. Okay, 3y is still negative, good. Hey, 24 is still negative. So no value is changed. Okay?
So you just changed the negative to a positive, and the numbers remain the same?
Yes. You got a negative in the middle, subtraction in the middle, change it to adding the opposite, adding the negative. And then that's not going to bother the 24. Then it's a legal move. You got your plus in the middle. And if there's a plus in the middle, it's not illegal to put parentheses around the front and the back, because it's not going to change the sign of that second group.
Is it always, or look at the whole thing first?
It's always. If this is subtraction, it doesn't matter what these are. If the middle one is subtraction, you always do this. Yeah. Yeah, there's no decisions to be made, no ambiguity there. You always do it. Okay, so now you've got your four terms and your grouping. Here's your four-term sum, and you have properly grouped it. Your GCF of the first group, and your GCF of the second group is what? Yeah? Except, here's the thing. What we're doing here in this step is your little GCF, right? But if you had to make this change, okay, then this second GCF should be negative. Because if you had to make this change, look how you have a leading negative. That'll help you remember. Okay, so if you make the second GCF is negative because, this is just shorthand for because of the operation flip. Operation meaning a subtraction to addition. So because of the operation flip, you want that second GCF to be the negative version. Okay? And the fact that it's a leading negative hopefully will help you remember that. Okay? So that is, instead of 3 is the GCF, but you're going to divide out negative 3. Now if you forget and you divide out a positive 3, what you're going to end up with is binomials that are opposites. Okay? and it's fixable, then you just have to go back and divide out a -1 to flip the signs. But why make extra work for yourself? That's just an extra step. Why would you want to take the GCF out of here twice if you can do it once? If you know you made this operation flip, then your second GCF is negative, period. Okay. All right, so that gives me that X up front, leaving behind Y plus 8. Now, if I got plus, and then, like I should, but if I'm pulling out a -3, I can go ahead and change that back to subtraction. Plus a -3, I'm pulling that out, is just subtraction. That's not a problem now. It's not a problem now to have a minus in the middle. Huh? So I pull out that -3, plus a -3, can go right back to subtraction, put my parenthesis up, and I'm left with, now be real careful here, those negatives cancel out, leaving me with, if you pulled out a +3, you'd be left with -y, opposite of this. Okay? Here I've got two negatives, so this is, yeah. If I did a -3, I'd end up with -8, which is opposite this. That's opposite binomials, and you'd be like, wait, my y's and 8 is the same, but they're opposites. And if they're both opposites, you have opposite binomials, it's like, oh, I forgot to take out a negative GCF. You can fix it, but why make more work for yourself if you catch it at the beginning? Okay, okay, so now this has become a two-term sum. Okay. Now, I'm going to show, instead of dividing out the big GCF, I'm going to show you my shorthand for doing it, because you're going to see it whenever I write out solutions, so I want you to know what you're looking at. Whatever strategy works for you, you can keep ow! You can keep doing it the same way you've been doing, or not, okay? But this is what I do. I say, oh, I've got my two terms, and they have that y plus 8's match, so I'm just going to underline it, okay? Just the y plus 8, or I might put a double underline under it because I don't want it to look like a division bar. I'm just noting, hey, this is the GCF. They have it in common, so I'm going to go ahead and write it down, y plus 8, and put up my parenthesis, my next parenthesis. And then, so I know when I've divided those out, what's left behind. And that's what goes in my second set of parentheses. So that's just kind of a shorthand way of noting I'm still just a shorthand way of saying I'm taking out the big GCF. Okay. So you're going to see me mark it up that way from now on. That's what it means. But if you prefer to mark it up in a different way, if you're getting to the right answer, that's fine. Homework is the time not just to practice the skills, but to practice your strategies, which can be my strategies or ones you already have or ones you develop that work for you. Everybody's brain is unique. Okay. And of course, you can FOIL to check. But what we've ended up with here is, just like we wanted, no more plus sign in the middle, plus or minus, and we've ended up with our product of two factors, specifically two binomials. Okay. Questions? I'm going to have to be kind of speedy in here because I want to get to the same place the 8 a.m. class did. I wish I had time to practice for you, throw these to you to practice more. Practice them on homework because these two examples are everything. The rules you see, there's no exceptions. The rules you see are the rules. Okay? It's either plus in the middle or a minus in the middle. Okay? So practice those this weekend and send me questions or be ready to ask questions on Tuesday. I want to show you, at least introduce one more method so you have more to work with and work ahead. It'll make Tuesday a lot easier. Okay? So I may go a little fast. All of it's going to be on the PowerPoint, and also I'm available to answer questions as well. So going back to the slide, hopefully it's not as confusing looking now, I hope. Okay? And you can see actually more table bar divisions here when you're actually looking at it, not blasted out up here. Okay, so you start with a 4-term sum. You take out two groups, little GCF, you end up with a 2-term sum. And then they have matching binomials, so that's your big GCF, which gets pulled out front. New parenthesis, and the leftover bits make the second one, and you end up with a product of two binomials. Okay? That started out here with a plus in the middle. If you start with a minus in the middle, it notes you must have plus in the middle, so you change that minus to plus and negative, so that last term is still whatever it was, plus it might be plus or minus, but it's not affected. Okay? Now you can legally put up your two groups with a plus in the middle, 4-term sum, but it notes for your little GCF, make sure that if you did that sign, that you do the sign flip, is that you the sign or the operation flip, that you pull out the second one, the purple one is you pull out a negative GCF. Now something went wrong, some glitch here, didn't save right. I need to fix this. because this right here should actually look like this over here where I got the little GCFs. So I'm going to fix that in the table. So you can see pulling out the x squared here and pulling out the negative 5 here. And you can see that pulled it out. The x squared and the negative 5 got pulled out. And when you pulled out that negative 5, that plus and negative 5 became negative 5. Okay, it became minus 5. Okay? And then they had matching binomials of 3x plus 5. That's the big GCF, leaving behind x squared minus 5. Does this make more sense now? Is it more? Because I know the first time I put it up, I was like, too much. Yeah. But those are the two. That's it. Okay. I'll fix that table in the second one to show that little GCF thing. But yeah. Okay. So let me jump forward to this is the beginning of 9.2, and we're just looking at quadratic trinomials. Now, all a trinomial is a 3-term polynomial. Okay? You can have 3-term expressions or 3-term polynomials, and there's infinite possibilities. And most of them are not factorable. Okay? We're factoring a very specific category of trinomials, the quadratic trinomial that is of the form ax squared plus bx plus c. What degree is this? Yeah, the highest exponent tells you the degree. It's second degree. Another way of saying it's a second degree polynomial is to say it's a quadratic trinomial. And just like a 2-variable linear equation can be graphed as a line, a 2-variable quadratic trinomial or second degree trinomial will make a parabola. So this is another family. Okay? These are the kinds that we can factor. You've got a whole bunch of other stuff going on. It's a trinomial, but the terms don't look like that. You've got a quadratic term, a linear term, and a constant. Okay? The highest one is the quadratic term, which makes the whole thing quadratic, but a quadratic term, a linear term, and a constant. Now, A and B are the coefficients of, A is the coefficient of the quadratic term, and B is the coefficient of the linear term. And then C is a constant. So A, B, and C are numbers, real numbers. Okay? So when we factor a quadratic trinomial, if it's of this form, then this is a method I use. There's multiple methods. If you already have one you're comfortable with, or you want to explore other methods, that's fine. I find this to be the sort of simplest and clearest and most consistent. So this is what I go with in class, but I'm happy to discuss other ones with you if you want. Okay, so I use what's called an ACB method, and this is how I organize it visually. Okay? Now, this is the only step you have to do if A, your quadratic coefficient, is equal to 1. If A, your quadratic coefficient, is not equal to 1, then you will still do exactly the same thing, but then there will be a second step. Okay? That we're going to get into more on Tuesday, but I want to at least show you the ones where A equals 1, because that's a one-step thing. Okay? So the ACB method is another way to sort of unfoil. Now let me be real specific. AC, when I say AC, what that means is A times C. So it's your quadratic coefficient times your constant. And if A equals 1, then what is AC going to equal? If A is 1, then AC is just 1 times C. So whatever C is your AC. But I still write it as AC because I want you to see when we have A not equal to 1, nothing's different. Okay? So ACB, if A is 1, then that's just 1 times whatever your C is. So it's your C. And so the setup is this. You put your AC, you multiply A times C in the top with the multiplication sign, and you put your B, which is your linear coefficient, on the bottom with a plus sign. And you're going to find a magic pair of numbers. K is just another common algebraic letter to use for constant. I didn't want to use C because C is part of the form. So K1 and K2 means you're going to come up with this magic